In example 4, we have another type 1 improper integral, but here we've got problems at infinity on both ends. We're integrating negative infinity to infinity x over x to the fourth plus 1 dx. So here's the graph of x over x to the fourth plus 1. And what we're going to do when you've got improper on both ends, what you do is you break that integral up to the integral from negative infinity to 0 of x over x to the fourth plus 1 dx plus the integral from 0 to infinity of x over x to the fourth plus 1 dx. And then in order to get an answer for the integral that we're looking at, we need both pieces here, integral negative infinity to 0 and 0 to infinity. We need both of those to be finite. And in that case, we'll actually get a finite answer for our integral. We say it converges. Now, when you first look at this, your intuition is, oh, this integral is just 0, right? Because we got symmetry here. This positive area will cancel out this negative area. Well, what if this is infinity? Then this one would be minus infinity. And if you add those together, infinity minus infinity, that's an indeterminate form. Remember L'Hopital's rule? So if this is the case, we would say it diverges. Now, in the other case, we get a finite number here and a finite number here, then they'll cancel out and we'll get a value of 0. So we don't know what's going to happen here. Well, what's our intuition? Looking at this piece here, dominant terms, x over x to the fourth, 1 over x cubed. So I'm thinking that that's going to be finite. So what we're going to do is we're going to look at one piece. So we'll look at this piece here. And by symmetry, if that one's finite, then this will just be the negative. So I'm going to look at the integral from 0 to infinity because that one's a little easier to deal with than the negative infinity to 0 of x over x to the fourth plus 1. So we're going to change this to integral from 0 to b, x over x to the fourth plus 1 dx, and then take a limit, letting that b go to infinity. Okay, so now we got a finite interval. How are we going to tackle this integral? Well, the derivative of the bottom would be 4x cubed. We've only got an x up here. However, if we write that bottom as x squared squared plus 1, now I see a function and almost its derivative, right? If u is x squared, then du would be 2x dx. So we can again multiply by 2 and 1/2 to compensate. And we will let u equal x squared. So doing another u substitution. And so your du is 2x dx. And let's go ahead and change this integral over to write it in terms of u. So this will now be limit b goes to infinity. Got a 1/2 out in front. 2x dx up on top, that's our du. And then in the denominator we have u squared plus 1. And now we have to change our limits of integration over. So if you plug a 0 in here, you get 0 squared, so that's still 0. But if you take x equal b and plug it into your u sub, you get b squared. And then do you recognize the antiderivative of 1 over u squared plus 1? Remember that that is inverse tangent. So this is limit b goes to infinity. Got that 1/2 out in front. And then this will be inverse tangent of u. And we're evaluating from 0 to b squared. So limit b goes to infinity, 1/2, And then we're plugging in b squared, plug in 0, and subtract. So inverse tan b squared minus inverse tan of 0. Now remember, inverse tangent means the angle whose tangent is. So the angle whose tangent is 0, that is just 0. And then inverse tangent b squared, b is going to infinity. The angle whose tangent is infinite. So remember that that is pi over 2. So this the limit here of inverse tan b squared as b goes to infinity is inverse tangent of the angle whose tangent becomes infinite. That's pi over 2. Remember that your inverse tangent graph looks like this. Got horizontal asymptotes at negative pi over 2 and pi over 2. And it looks like this. That's inverse tangent. So as b goes to infinity, what you're putting inside the inverse tan goes to infinity. You go out here. What happens to inverse tan? It approaches pi over 2. So this is just 1/2 times pi over 2, which is pi over 4. So we've got a finite value. So this area is pi over 4. And then by symmetry, this one's going to be negative pi over 4. So our final answer here, this will be negative pi over 4 plus, and then this one's your pi over 4. And since they're both finite, that does indeed give 0. So if they're finite, they do cancel out, but not when they're infinite. If this answer would have been infinity, we would just said, hey, it diverges.